Measurements are what really make numbers come alive and really give them meaning. So, to start with, here's a basic overview of the first three major quantities for measurements. And we have two major systems that we're really going to talk about here: the customary system that we use here in America, and then the metric system that's used throughout the world. The major quantities that we're going to work with are length, mass, and volume. And there are two other major quantities we also work with. We work with time and temperature as well. Temperature has a very specific formula, as you can see here. And time is the one universal one because we all follow the same structure or calibration for time everywhere in the world. It's not a different measurement anywhere. So that's the one universal one. And it actually uses the metric prefixes to help understand it. So like seconds can be read as milliseconds or nanoseconds to look at the size in there. So let's look at a chart of those metric prefixes. As you can see here, we've got a list of the major ones. None there in the middle, the one that's referencing meters, grams, liters, the base value for length, mass, and volume. From there, we look at them as multiplications of 10, either really, really large, multiplying by 10 more and more to get up to, say, like kilometers or gigameters, or dividing by 10, getting really, really small, looking at, say, like micrometers or nanometers, something like that. And then on the other side of things, we have the customary system of measurements, which are based on these units and those symbols. You'll notice these equivalencies have very specific numbers attached to each of them, and they're based on their equivalency to the other numbers, on how they were built or matched up historically within those systems. So there's some more memorization in there in terms of having to memorize or remember the numbers that associate each unit to each other. So, how there are 2,000 pounds in a ton versus 16 ounces in a pound. So those relationships are important. Sometimes you're going to have to look up this chart to work with problems, just like this chart is necessary to look up, which shows the customary to the metric system. So we have to go from one system to the other. So here's a couple of the equivalencies for length, mass, and volume. The really important ones like inch to centimeter or pounds to kilograms, things like that. So let's look at some examples and how we convert. So what we want to do is we want to take the number, evaluate what is the unit that's given so that we can find the equivalent unit to the unit that they're looking for in the new value, the new conversion. So let's start with looking at this example with 483 grams, and they're asking us to convert it to kilograms. What I want to do is figure out, well, how many kilograms are there in a gram, or how many grams are there in a kilogram? And what I know is that 1 kilogram is to 1,000 grams. So I can set up this multiplication of an equivalent fraction. So now when I multiply 483 by 1 over 1,000, hopefully I'm dividing, that's going to give me the new number of 483 thousandths of a kilogram. So now I know how much 483 grams is in kilograms. So let's look at another example. Here we have 3 and 58,134 100,000ths decameters. And we want to convert that or look at that in millimeters. So I need to know what the equivalency is of millimeters to decameters. And I look at a chart and find that we have 10,000 millimeters per 1 decameter. So setting up this fractional equivalency and multiplication next to the original decameter amount, now I look at a multiplication problem that's going to convert it and give me my ultimate value, which is how many millimeters I'm looking at. So that converts into 35,813 and 4/10 millimeters. So what's important to see with the metric conversions is that I'm ultimately looking at a chart to see how far or how many values of 10 the units are away from each other. So in this example that we're looking at, decameters and millimeters have 4 values of 10 between them. So that's why I have 10,000 there in the multiplication. So let's continue to look at some more examples and show how we're working this. Again, we're looking at the distance between them in values of 10 when we're looking at the metric system. So here we're looking at 23 milliliters, and we're looking to convert that to liters. So I want to figure out what is the fractional equivalency of milliliters to liters. And that's 1 liter per 1,000 milliliters. So in this case, it's going to set up with the multiplication a division problem. So when I multiply that through, I'm looking at moving that decimal 3 placeholders to the left to give me 23 thousandths of a liter. So as you can see with the metric system, we're really just moving the decimal place from left to right, and the numbers are going to stay the same. We're just bringing in some zeros and putting the decimal in a different place. So in this next example, we're going to convert across systems. So we're going to have to look up a different equivalency. But in this case, we're going to take 7,924 centimeters and want to convert that to feet. So I need to know how many inches there are in a centimeter. So when I set up that equivalency, I'm multiplying or dividing by the correct value. In this case, we know that 1 inch is to 2 54 of a centimeter. So when I put that multiplication in, I'm ultimately dividing to give me 3,119 and 685 thousandths of an inch. Now I'm going to have to multiply that by the equivalency of a foot to an inch so that I can ultimately convert this into feet, which is going to give me 1 foot to 12 inches, which is going to be another division problem, giving me the final answer of 259 and 974 thousandths feet. So there's a little more to keep track of when we're converting across systems and also when we're working within the custom area system, because the equivalencies aren't based on values of 10, they're based on other numbers, so we have to make sure that we're putting those values in the correct location in terms of multiplication or division. So here's a couple more examples, and then we're going to do some examples here in the custom area system to show how those numbers change up your value. So let's look at 427 tablespoons and converting that into gallons. All right, now this is going to make the new number really, really small, but I need those equivalencies to see how I'm going to get there. So we're going to start with an ounce to 2 tablespoons. There's a cup to 8 ounces. There's a pint to 2 cups. There's 1 quart to 2 pints, and 1 gallon to 4 quarts. Now I have to set that up so that when I'm multiplying across, I'm getting rid of and moving the right way through the values. So we'll say we're kind of like canceling. Tablespoons cancels with tablespoons, leaving me ounces. Ounces cancels with ounces, leaving me cups. Cups cancels with cups, leaving pints. Then pints cancels with pints, leaving quarts. And then quarts cancel with quarts, leaving gallons. And that's ultimately how the conversion works, leaving that final number to be the amount of gallons based on that original amount of tablespoons. So in another example, we're going to look at, in this case, going the other way, miles to inches, and essentially a large value to a really, really small unit. So that new number is going to become larger because there are 5,280 feet per mile and 12 inches per foot. So in this case, when we set them up, we're going to have 3 values that are multiplying together, making that number larger and larger, ultimately telling me how many inches, which would be a lot of inches, fit into 7 miles.